Yeah, thanks a lot. Thanks for coming to the very last session of the conference. And today we're going to see together how we can scale a food app when we have 10,000 pizza reviews, but none for deconstructed carbonara. So just a bit about me. So I'm a senior machine learning scientist at Monzo, where I work on LLM capabilities for customer support. And previously, I was working at Bumble, where I worked on LLM-powered moderation pipelines. And if you were in the previous talk before, I used to work with Adam at Comply Advantage, where we were using LLMs to detect financial crimes. So I've worked a lot around catching bad actors, but today's topic is going to be about foods. So what we'll see together is how we can categorize reviews for a local food app. And the challenge is that we need to identify the intent and the sentiment across a diverse set of cuisines. And of course, as you can imagine, we have like a lot of reviews and a lot of things available for standard foods. But when it comes to more like niche markets, there's quite a data desert around that. So as you all know, probably when it comes to having more data, it's often quite a slow process and that can be quite expensive. You need the right people to be able to annotate your data, and sometimes the data is just like not existing at all. So for our study, we're going to see how we can launch in a new city the molecular gastronomy scenes. And well, the challenge we have is, of course, we have a lot of things about fast food language, but yeah, not a lot about the new markets. So let's see how we can close that gap. So first, why is it a problem to not cover this edge case? Well, because if we have a model that's trained on like Good Burger, it's not going to understand the format's aggressive salinity, because it's so different that you won't be able to generalize from one domain to another. And the danger is that you can have like biases and blind spots in your data set, which makes it that overall you can have high accuracy, high precision, but when you look at those particular cases, the model can actually be pretty bad. In traditional like data augmentation, there was a lot of things that were done around, flipping the image, cropping the image, rotating it. In text, it was more about, how we can replace a word by its synonym. But it was mostly just surface level changes. And it was, in the end, just like very little change, not big ones like the ones we're looking for. So what can we do about that? Well, I'm going to present 3 techniques using LLMs, how we can mix them all together, what are the limitations and challenges, and how we can validate those techniques. So the first one is synthetic data generation. So for this, it's quite simple. You're going to prompt your LLMs to generate new labeled examples. So for example, you can say, I would like some examples of reviews about this particular type of cuisine. I want some that are positive, some that are negative, and give some examples of what you would like. It can be quite useful for rare classes or intense or edge cases. And also when you're launching a new product, just think about that. You may just have no data at all. So what would it look like for the foodie app? Well, we can think about, generate 50 reviews for nitrogen-chilled desserts. Some should be amazed by the texture, others frustrated by the temperature. And the output we're going to get is essentially a balanced data set that includes molecular gastronomy, and we won't have to wait for like 1,000 real customers to visit and leave a review. So that's for the first one. Another thing we can do is essentially to use LoRA adapters. So LoRA adapters are essentially low-rank matrices that we are going to introduce. So we're starting with a foundation LLM. So you can think about any open source families. And we are going to freeze the weights. On top of that, we introduce 2 smaller matrices that would be of low rank. And then what we are going to do is we are going to fine-tune the sum of the 2 matrices, and we are going to update the weights of A and B. So think about it a bit as, you have a pre-trained embeddings, you're training it on specific data to get your final model. And the good thing about it is that actually you don't need that many data, and it's not that you need like, okay, super expensive GPUs to do that. If you look at an examples, let's say we're taking Llama, so it's like 8 billion parameters for one of the cases. And actually, you only need to train about 4 million parameters in the end. So even with like a small GPUs, it can be quite quick to do. On top of that, you don't need a whole lot of training data for that. In most of the cases that I've used it for, just 100 data was already more than enough. It's also useful when the prompts alone are not sufficient, or when you're looking for a specific tone or a specific style. So in our case, for the food app, what we could do is we could take some Michelin guide reviews. We fine-tune it on those 100 reviews, and then we just like ask it to generate some similar style. And as the outputs, we can expect to have more culinary vocabulary compared to before. Finally, last techniques, when you have some real-world data available, is to essentially use LLMs to label your existing data. So what you can do is you would have a prompt that says, okay, I have like these labels, this is my text, and give the correct label to the correct piece of text. So it scales pretty well in a lot of cases, not just simple text, but also dialogues, or if you mix pictures with text. But the thing is that it's going to require stronger validation, and probably you want a bit of human in the loop for quality assurance. So in our case, what we could do is we could scrap from some comments on Instagram, and then just classify the intents as either positive or negative, give the message in the contents, and then as the outputs, we are going to get the labels for the data. So essentially, we turn raw text into training data. So this looks good, but when to choose each of the techniques? So for synthetic data generation, as I said, it's really when you don't have any of the data. So imagine you want to come up with your restaurant about Mesopotamian fusion. Have no idea what it would sell, but would love to try. So okay, these are the cases where you would go for synthetic data. When you have the case where the style or the tone particularly matters, you would probably want to go for fine-tuning the LLM using LoRA techniques. And finally, when you have plenty of raw text available, you can go for LLM annotations of your real examples. So if you think about it in a bit decision tree style, you ask yourself first, okay, do we have any data available? Yes or no? If not, let's go for synthetic data generation. Then does the style matters, the tone? Are we likely maybe to miss some edge cases? If yes, we can go for fine-tuning, if not, LLM annotations. But think about it as everything can be combined. So you can release your new products, you don't have anything, go for synthetic data generation. Once the product is released, then you can either go for fine-tuning or annotations. And what if you want to expand to new languages? Well, now imagine that's okay, we have built our reviews in English, but we also would like to expand to new European languages. Well, actually, the same techniques would work pretty similarly. We'll see a bit later in the talk that we may need some extra validation for each of the languages, but all in all, it's pretty similar. This all looks good, but what can go wrong? Well, actually, a lot of things, so let's take a look for each of the techniques. Well, first one, for synthetic data generation, well, it's generated by AI. So as you can imagine, it can be like overly clean language. Just think about the responses from ChatGPT sometimes. Yeah, it doesn't really feel like a human would have written that. We also lack kind of the user noise. And of course, it's not going to match your true distribution. So I kind of miss the messiness of the real world. For LoRA fine-tuning, well, I would say the biggest risk is that it may overfit too much your input examples. So as when you are training embeddings, like if you train too much, you will have overfitting. And it's going to, in the end, reduce the lexical diversity. I would say the biggest risk is if you fine-tune on English and then you want to generate, let's say, German, it may kind of lose actually the German language when you fine-tune. Of course, it's highly dependent of the examples that you give as inputs. So I would recommend, if it's not working for some examples, maybe try more diverse ones or less epochs. For LLM annotation, I would say the main issue is that it can be very confident at giving the wrong answers, and there can be a bit of systematic bias. We'll see a bit later, but it can be that, okay, in fast food, when you say that the food arrived cold, probably it's more a negative review. But if you talk about ice cream, then okay, maybe it's a positive one. So you can have this kind of systematic bias, which in the end is going to amplify the error that you have. In terms of the practical flow, so you're first going to determine what's your data gap, so where you have essentially your edge cases. You're going to choose which model you're going to use, whether you go for open source or third parties, which tools, and then you're going to write your prompts, generate and filter the cases. So the first one about defining the goal. Well, you need to be specific about what you're missing, so which part of the diversity you actually need. So let's look at an example. Give positive reviews about nitrogen-related dessert that could be written by a French person aged 30 to 35. Well, in this case, it's clear because you have which label you get, so positive reviews. You have some kind of scenario that you want to generate, which is nitrogen-related desserts. And on top of that, you also have a persona. Okay, so it's a person aged 30 to 35. So with this, like, you're more likely to get more diversity out of it. And yeah, just really avoid just vague goals like, okay, more data about desserts, because this is going to give you too much of the same thing. Because in the end, generation is easy. It's quite like simple generation loops, and if you just need more, well, it scales quite easily. If your data is not diverse enough, you can think about, okay, including more scenarios, having more personalized or changing the tone, but it's really the quality control that's the hard part of it. So, as you know, as we've discussed, the synthetic data that you generate can be either wrong or biased. LLMs can have hallucinations, mislabel your data. So we really need to actually validate the data that comes out of it. So how to do that? Well, first, I would say the ideal case when you have the possibility is to have human agreement checks. So you could, for example, send 5% of your data that's either generated or LLM annotated to humans and see essentially if they agree with it or not. You can then measure the disagreements. And what's important is not just whether the LLM is right or wrong, but also how the differences are. Because there may be that, okay, on majority of the cases, human and LLM agree, but for this particular edge cases, it tends to be always wrong. Another method would be to use LLM as a judge. So in that case, you would use a separate LLM to essentially verify your annotations. You can check on several things like, okay, is this relevant? Is this correct? Whether it's aligned with your policy or not. And this works quite well with complex labels. Now, when it comes to this, I know that we often would like to have like a score about how much the LLM is actually confident about the label it's given. So some people are asking the score as part of output of the LLM, but this often doesn't work because when you ask for the output of the LLM, it's actually a string that's returned and not really a float. So there's one thing that you can use to get something closer to the probability, which is essentially the log probes. So what the log props are is that, as you can imagine, when the LLM is generating your outputs, it's generating token by token. So under the hood, what it does is that it's got a dictionary of all the available tokens, and for each token, it has a probability associated to it. And this is something that you can actually have within your LLM. So what's actually stored is what's called the log props, which is just the logarithm of the probability of the token. And it's available with most of the APIs. So of course, for open source LLMs, you have access to probability of all the tokens. And there are some third parties that also allow it. So let's see an examples in how to use it. So we have this review. The reduction gave an earthy flavor. So if you were like me a couple of days ago and have no clue about what it means, I didn't know either. But we can essentially go for the tokens for positive, negative, and neutral, get the log prop out of it, and then infer the probability of each one. So it's a bit saying, okay, so the LLM is predicting positive with a confidence score of 90%. And that's a nice way to have something that's closer to your normal probability that we would have in classical machine learning models. So yeah, how we can use it for annotation confidence. So essentially what you would do is you would compare the log props of the candidates that you label. So it can be like quite fast and cheap. It's often an alternative to self-consistency, because if you think about it, in the end, it's doing more or less the same thing, and it gives you a confidence score for each of your annotations, essentially for free. So in practice, how you could imagine doing it is, okay, you have your prompts, you say, okay, this is the text I want to label, these are my labels, which one is the correct one, and then you get your log props for each of your label. If it's below the threshold, you can like send it to human review. If it's above the threshold, you can automatically accept it. There are, however, some limitations using the log props. The first one is when the model is super confident, of course, it doesn't mean that it's correct, as they can be systematically wrong on particular edge cases. As I mentioned before, usually like when cold is associated to the food, it's often seen as something negative. So for some LLMs, they tend to predict a lot that the review is going to be negative, even though sometimes it's just like talking about something that actually should be cold. So where log props can be useful is more to catch essentially the uncertainty between some of your answers, but it's not going to remove the systematic bias. And of course, you still need some kind of human agreements to check the edge cases or the uncertainty that can be found. On top of that, you can also use some semantic quality metrics to check the data that's been generating. So one thing that you can do is use very simple ones like Bleu or Rouge score. They can be quite limited, but a good first way to get somewhere. Other than that, you can also use embeddings to check the similarity, and it's often going to be more reliable. So the idea in here is that you're going to check all your generated data that's got the same label. You check what's the cosine similarity within your cluster, and you're going to compare it to the cosine similarity of the other clusters of labels that you have. What to do when it turns about multilingual? Well, as we've seen before, if you want to generate in different languages, most of the techniques would actually be the same. You can also think about translating your full context from English if it's needed, or if you don't have any data in your particular languages. But this would require essentially a validation step on top of it for your particular language. So let's see what it would look like. So in terms of which step to add, what you want to see is essentially first, was the correct language generated, and see that it's not a mix of English and your other language. So you need to check for semantic scores, and also check whether this is actually grammatically correct, and this could actually be generated by a real person or not. I would say when it comes to multilingual, if you have human reviewers, it's really much better to have native speakers, because they're going to be able to see where you have systematic errors. So yeah, really important steps to incorporate to it. So let's see how it's puts everything together. So let's imagine we have the niche food reviews. We're running either self-consistency and LLM as a judge, or we're checking the confidence score from the log probes. We're adding the high-quality filter data to our original pizzas and burgers sets. And at the end of it, we get our Foodie AI app. But this is something that we haven't tested, because we still don't know whether this actually helps, or if just not having anything at all would have been better. So it's important to compare essentially the downstream model impacts with your real data only, with the one where you include your synthetic data. So what you're gonna do is you train your model with the real data, so without everything that you've just added, and then you can train it with all the changes that we have talked together. And you're going to compare how both models are doing on testing data. You can also compare across multiple languages if you need. And what you're going to look at is essentially first put the focus on this where classes, these edge cases, to see if it's performing like better or not. And also take a look at the overall distribution and your calibration. Because what can happen is if you add too many of the edge cases, okay, the model can be very performant on this, but then overall it can actually degrade quite a lot the performance. So it's important to take a look at how is your calibration overall, and what does the error distribution actually look like. In terms of the challenges, well, this can get quite expensive as you want to move to more data, especially if you go for third parties. If you need to do hundreds of thousands of reviews, it's going to cost you really a lot. There can be some systematic bias, especially when it comes to experimental folds. There can be a shortcut that by the LLM thinking that it's going to be expensive. And of course, as you've seen, there can be like still variety across different languages and different edge cases. On top of it, as we've talked about generating synthetic data, it's really important to think about your data governance, and think about it as, okay, we need to be transparent about how we have generated it, make sure that you are not fine-tuning your LLMs on PIIs of your customers, because yeah, this could go pretty bad. And yeah, make sure that everything that you have is documented, and everything just falls in place. In terms of key takeaways, so you can use your LLMs to essentially create your data, refine it, label it, not just as end-to-end models. Think about LLMs as not just your production pipelines, but also as an alternative to your data annotation pipeline. You need, of course, to validate your synthetic data, and the goal is to have a high coverage and not just have the volume. And if I were to leave you just with one thought, it would be that without the validation, using LLMs for data augmentation is only gonna move the bias that you have upstream, and with it, it can be a powerful lever to scale. Well, thanks a lot for making it for the end of the talk and the end of the conference as well. And yeah, you have a QR code for my LinkedIn.
Thank you.